Hello, welcome back to my recorded classes. This recorded video, we are discussing the topic from module number 5, discrete probability. The first topic 5.1, probability theory. Just introduction to the probability theory. So 5.1 section, we have two exercise as we know. Exercise 5.1.1 and exercise 5.1.2. Okay, 5.1.1 we are discussing about the sample space, and 5.1.2 we are discussing about the probability theory introduction. Okay, so before starting the topic, all of you please subscribe my channel for getting more recorded classes. So in module 5, discrete probability, you can see what are the topics we are discussing. 5.1, we are discussing probability theory, like a sample space, event, probability, axioms, joint probability, independence, like these things. And 5.2 later we will upload conditional and marginal probability. 5.3 very important topic, bias theorem. And 5.4 expected value and variance. So these are the topic from module number 5. So let's start the first topic, that is 5.1 probability theory. So module 5 discrete probability, some of the application we can see first. Okay, it is the topic from statistics. Okay, a few applications of discrete probability in computer science. Example, analyzing behavior of algorithm that make random choices, for example running time, performance, like that. Testing computer system, generating input demand to test a system, etc. Modeling a discrete structure, understanding the structure of the internet or social network. So a lot of applications are there in the computer science field and all other fields also, especially algorithm design and game theory and information theory, signal processing, cryptography. Okay, these are all the some of the application field regarding the discrete probability. Okay, so let's start the content. 5.1 section, probability theory, sample spaces, event, probability axiom, joint probability, and independence. So let's start from the basics of the probability theory before. Okay, how to find the sample space, like these things. So just start some of the basic idea first. Okay, I will just show in fastly some points here. Experiment. An experiment is defined as an action, correct? Experiment means it is an action which can produce some well-defined result. From that we are getting some well-defined results we are getting, correct? If you are conducting one experiment, experiment means an action, it will produce some well-defined result here. Now, experiment can be classified into two ways. One we are calling deterministic experiment or predictable experiment. Okay, and the second one is non-deterministic experiment or random experiment. Okay, or unpredictable experiment. Okay, one is deterministic and second one is random experiment. Now you can see deterministic experiment or predictable experiment. What is the meaning of that one? Deterministic experiment means an experiment is said to be deterministic if the result of the experiment can be predicted with certainly prior. Okay, when we are conducting one experiment, that experiment result we can predict prior to that one. Okay, before that itself we can predict what answer you are getting correctly, we can predict that one. That type of experiment we are calling deterministic experiment or predictable experiment. Let's see some example here. You can see some of the example here. If you are throwing a stone towards the sky, correct? If you are throwing a stone from here to sky, automatically it will come down, correct? It will fall to the earth due to the gravitational force, correct? So we can predict that one, what happened. So this is deterministic experiment, correct? Now, when we perform an experiment in science lab, correct? In science, physics, chemistry, we are doing many experiment, correct? And repeat the same experiment under identical condition, we get almost same result only getting, correct? We did some of the experiment in physics lab, chemistry lab, correct? We know what experiment answer we are getting, correct? If we are doing same experiment repeatedly under the same condition, we will get almost the same result only. So this result we can predict that one, correct? So this type of experiment we are calling deterministic experiment. I hope you understood that one, correct? Now we are going to the second category. That is what important category here. Second one, non-deterministic experiment or random experiment, unpredictable experiment, correct? Outcome we cannot predict prior, correct? Before conducting that, before the conduction of that experiment, we cannot say what is the outcome we are getting correctly, correct? So that type of experiment we are calling non-deterministic experiment. So an experiment is said to be non-deterministic if the result of the experiment cannot be predicted, okay, cannot be predicted with certainly prior. That is what the random experiment. For example, if you are rolling a die, you know what is the meaning die? This one, when we are playing, we are using this one, correct? So this one. So when we are rolling a die, we don't know what outcome we are getting or which side it will come. One die, we have 6 faces are there, correct? What are the number it is mentioned in the 6 faces? Number 1 dot will be there, 2 dot will be there, 3 will be there, 4, 5, 6, correct? 6 option will be there. So if you are rolling a die, when we are playing, we don't know which face will come on the top, correct? Which face we will get it or which outcome we will get it, we cannot predict that one, correct? From 1 to 6, any number it will come like that, correct? So outcome cannot be predicted certainly prior to that experiment, correct? So this type of experiment we are calling random experiment or non-deterministic experiment. Some of the example, another, tossing of a coin, correct? If you are tossing a coin, there are 2 options, either head or tail, but we don't know which will come correctly, correct? So head means this side and tail means this number side, correct? So we don't know which side will come correctly. So we cannot predict that one. This type of experiment we are calling random experiment. Hope you understood that one. Now this module, actually module 5, okay, we are completely dealing with the random experiment, non-deterministic experiment, okay, not predictable experiment or random experiment. We are discussing the module number 5, probability theory or discrete probability module. Okay, now you can see some of the ideas, some of the definitions, small definitions. Trial, what is the meaning? Trial means, the term trial refers a single random experiment. What is the meaning? Trial, a single random experiment performance. That is what we are calling a trial. For example, rolling a die. Okay, we have a die, we are just rolling that die. Okay, a single experiment, that one, single random experiment, correct? So that is a trial, one checking one time, correct? That is one trial. Tossing a coin, we have a coin, we are just tossing one time that coin. That is what we are calling trial of that experiment. We are doing one time, one trial, 2 trial, second time means second trial, third trial, like that. Okay, so trial of an experiment means it's a single random experiment performance. Okay, now outcome, what is the meaning outcome? Outcome means the result of a trial is said to be, result of a trial, that is said to be an outcome. For example, trial, what we told before, rolling a die, correct? Rolling a die, this is one single trial. If we are doing one time rolling a die, what are the result we are getting? Either we are getting number 1 or number 2, number 3, number 4, number 5, number 6, correct? So this one, the result of a trial. For example, one time if you roll the rolling a die, for example, we go to number 1. That is one outcome, okay, one of the outcomes. So totally how many outcome we have? We have 6 outcomes are there. Either we will get 1 or we will get 2 or 3 or 4 or 5 or 6, like that, correct? This is what we are calling outcome of a random experiment. Okay, for example, there are 2 outcomes when we are tossing a coin. When we are tossing a coin, what are the outcomes? Either we will get head option, we are representing capital H, or we are getting tail option, we are representing capital T, correct? So there are 2 outcomes for that trial, correct? Either head we will get or we will get a tail we will get it. Okay, now you can see another example. Okay, outcomes. For example, there are 6 outcomes when we are throwing a die. Just now I discussed that one. When we are throwing a die, we have one of the 6 outcomes, correct? For either we will get this phase number 1, or we will get this phase number 2, or number 3, or number 4, or number 5, or number 6. There are 6 phases, correct? One of the phase we are getting. So how many outcomes possibilities? There are 6 possibilities are there, correct? One of this phase we will get it here. I hope you understood this one. Now, when we are going to another example, this is also a very important example in probability theory, especially many ideas we can discuss by using this example. Drawing a card, okay, we are taking a card from a pack of well shuffled cards, okay, well shuffled cards, we are taking one card. So in a pack of 52 card, in a well shuffled pack of card means in a pack we have 52 cards, okay, we have 52 cards are there normally in a packet. So in this pack, normal card, there are 4 options in the card. What are the 4 options? Clubs will be there. Club means this symbol, this is the club card. Spade will be there. Spade card means this type of card. And heart card, heart means this type of card. And diamond means this symbol, okay. There are 4 types of card is there, okay. Now club means, you can see there are 13 cards, okay. You can see one by one, 1 2 3 4 5 6 7 up to the last card. There are 13 cards will be there. So how many options there in clubs? 13 card. How many spade card will be there? Same like 13 card. How many heart card will be there? That is 13. And how many diamond card will be there? That also become 13 cards, correct? So 4 options totally out of 52 card, 4 option, 4 symbols will be there: clubs, spade, heart and diamond. Now out of these 4 type of card, 2 types of cards are black color, correct? And 2 types of card, other 2 types of cards are red color. So you can see what are the black type card and what are the red color card. Club card and spade card, that is black color, correct? So 13 plus 30, 26 cards are black card, correct? And how many cards are red color here? Heart card and diamond card, these are the red card, correct? So how many cards are there? 13 plus 13, that is 26 cards are red color, okay. So totally 52 card, out of 52, 26 cards are black card and 26 cards are red card, correct? Most of you know this game, so nothing to, okay, discuss. I am just telling the idea only. Now out of these cards, again we have some categories. You can see here ace card is there, correct? How many ace card? Ace card means here you can see the A, correct? Capital A, you can see. How many ace cards we have? We have 4 ace card, correct? 4 ace cards are there, 1 2 3 and 4. And number 2, we can see number 2 marking. How many number 2 cards will be there? Again 4 cards are there, correct? 4 cards are there. Out of this 4 card, 2 cards are black color and another 2 cards are red color, okay. So same number 3 we have 4 card, number 4 we have 4 cards, number 5 we have 4 cards, number 6, number 7, number 8, number 9, number 10, all these 4 card. Then there are some special cards, jack card also 4 cards we have, and queen card we have 4, and king also we have 4 card, correct? So all option we are getting 4 cards are there, totally 52 cards we are getting. So this is the pack of card, correct? So how many outcomes are here? There are 52 outcomes are there, 52 cards are there, correct? 52 cards are there, but each outcome there are different possibilities are there. You can just make sure that one you understood that one, okay. Club, spade, heart, diamond and ace up to king options are there, many options are there, okay. So this is the idea about the card. So there are 52 outcomes are there, 52 cards are there in a well shuffled pack of cards, okay. So this is another example for the outcomes. So this one keep in your mind, this idea, okay. Many places we are using that one. So this is the rough idea. One standard deck of cards. There are spade card, heart card, diamond card, club card. Each symbols you can see it is given there. Spade, what is the symbol they are using? Heart, diamond and club. So spade we have 13 option, heart we have 13 option, diamond we have 13, club we have 13. Out of this, spade and club are black color, heart and diamond are red color. You can see the color there, okay. And each option A, ace card is there, number 2, number 3, number 4, jack, king, queen, all the cards will be there in all the option. King card, heart card, diamond card and club card, all these options will be there. 13 options will be there. Okay, hope you understood the idea about this card. Okay, now sample space, next point we need to discuss. Sample space, what is the meaning? Sample space, sample space means the set of all possible outcomes. What are the possible outcomes of a random experiment is said to be a sample space, and it is denoted by usually capital letter S letter. S means the sample space, set of all possible outcome. We discussed some of the example here. Each example, what are the outcomes we are discussed. For example, if you are tossing a coin, some examples you can see sample space. If you are tossing a coin, what are the options? Either head will be there or tail option will be there. So there are two outcome, one is head outcome, another one is tail outcome, correct? The set of all possible outcome, so this only the possible outcome, either head or tail, that together we are calling sample space of a random experiment. So S equal to H and T, head and tail. Now when we are throwing a die is throwing, what are the sample space? Either one will get it, either one will get it, or two outcome will get it, or 3 or 4 or 5 or 6. There are 6 outcomes are there. So set of all these outcomes we are calling sample space of a random experiment. I hope you understood that one, correct? Now so what I told here, when we are throwing a die, correct, when we are throwing a die, what are the sample space we are discussed? Sample space equal to 1, 2, 3, 4, 5 and 6, correct? Now next definition we are discussing event. What is the meaning event? It is also very important for the next sections. All the questions we are doing depends on events. So what is the meaning event? Any subset of a sample space, any subset of a sample space we are calling an event. Okay, for example, you can see this example. For example, here S equal to 1, 2, 3, 4, 5 and 6, correct? Now in module number 3 we are discussed how to write the subset of a set, correct? What are the subset of this set? Subsets, what are the subset? First, empty set, null set is a subset of all the set, correct? Now what are the other subset? Singleton set 1, set 1 is a subset, set 2 is a subset, set 3, correct, is a subset, set 4 is a subset, set 5 and set 6. All of you remember this one in module 3, how to write the subset. Power set we are studied, set of all subset, correct? Now what are the two numbers subset? 1, 2, correct? We can write 1, 3, 1, 4, like I am not writing all the subset, like two set number set we can write, correct? Now if you want 3 number subset, what are the 3 number? 1, 2, 3, correct? And we can write 2, 3, 4, another subset, like that many subset we can write, correct? Like that 4 number subset we can write, 5 number subset we can write, 6 number subset. Okay, all the subset we can write. Okay, now just I am putting the dot here. Now the full subset, what is the 6 number subset? 1, 2, 3, 4, 5 and 6, because all the elements is a subset of itself. Any set is a subset of itself, correct? So we are written empty subset, we are written empty set, 1 number set subset we are written, 2 number subset we are written, 3 number subset we are, 4 number, 5 number, lastly we are written 6 number subset, correct? These subsets we are calling event of a sample space. Any subset of a sample space we are calling an event. I hope you understood. So these are all event. This example, set 1 is an event, set 2, set 3, set 4, set 1, 2, 3 up to 6, all are the event of a sample space. Okay, hope you understood. Now here specifically some example here it is getting a head when a coin is tossed. Getting a head, what is that subset actually? E equal to, even usually we are representing capital E letter, any other letter also we can use, capital A, B, C, any letter we can use. For example, when you are tossing a coin, getting a head, what is the event here? E equal to set H. See, one event is there, correct? I can show that one. For example, tossing, correct, a coin. Tossing a coin means what are the sample space? Sample space equal to either head will come or tail will come, correct? Head or tail. Now, when we are writing the subset, correct? What are the subsets we are writing? First, empty set is a subset, correct? What is the another subset? Set head is a subset, one element set, correct? Set tail is a subset. Now, two element, what are the two element? Only one head and tail. These are the two element subset, correct? So these are all events, correct? These are all event. Set head, getting an head is an event. Getting tail is an event. Getting head and tail is an event. Okay, nothing. Phi is an event. So here we are written getting an head. We can represent by E equal to set head. Now getting an odd number when a die is thrown. Getting an odd number when a die is thrown. Die is thrown means what are the outcomes? 1, 2, 3, 4 up to 6. From that, getting an odd number. Odd number means what are the odd number? 1, 3, 5. Correct? Because maximum 6 only. So 1, 3 and 5. So these are the outcomes in the getting an odd number event. So event means just a subset of a sample space. You can clear like that one. I hope you understood that one. So this example, these are the event. Okay, and this example, these are the event. Now, specifically we are coming events. We are dividing into two categories. Two categories in which events can be divided. One we are calling elementary events. Okay, what we are calling elementary events. And second one we are calling compound events. What is the meaning of elementary event actually? Elementary event, or we are calling simple event. So a simple event is an event with a single outcome. How many outcome only? Only a single outcome. Only one answer. Okay, only one answer. This type of event we are calling elementary event. So a simple event is an event, only a single outcome. For example, these questions. Okay, what are the elementary event here? Only single outcome. For example, here, see, only one outcome, set 1. Only one outcome, set 2, set 3, set 4, set 5, set 6. These are all elementary outcomes. Okay, because only we have one outcome, correct? Elementary event, we can tell this one elementary events, only one outcome. For example, when we are tossing a coin, for getting a head, only one result, correct? Or getting a tail, only one result. This is what we are calling simple event or elementary event. Okay, simple events. Okay, so this is the idea here. Elementary event or single event, simple event means event having a single outcome, only one answer. Now compound event means a compound event is an event with two or more outcomes. Two or more outcomes will be there. Rolling a die and getting an even number. Like see, for example, here. See here how many outcomes are there? 1, 2 outcomes. Here also how many? 1, 2 outcome. Correct? So this is what we are calling compound event. Okay, compound event. 2 or more than. See, this is compound event. 1, 2, 3. Correct? We have 3 outcomes. So this is compound event. And this type of event we are calling compound event. Single outcome means elementary event. More than 2 or more than 2 outcome means compound event. See, this is compound event. Correct? Compound event, because more than 2 outcomes it is there in the example. So compound event. So I hope you understood what is the meaning compound event. Rolling an example here. Rolling an even number on a die. What is that event? In a die, correct? In a die. Die means what are the options actually? 1, 2, 3, 4, 5, 6. Correct? 6 spaces are there. Now out of this rolling an even number. Even number means out of this what are the even number? 2, 4 and 6. So getting an even number. This is a compound event. Correct? Because how many outcomes are there here? More than 2. Correct? 2 or more than 2 means compound. 1, 2, 3. So this is a compound event. Okay, so this is the example of a compound event here. So hope you understood that one. Okay, now we will go to null set or null event or impossible event. Null event means the null set 5. Null set 5 is called null event, and the sample space S is called sure event. Okay, sample space we are calling sure event, and empty set we are calling null event. Null means nothing. Null event or impossible event. It is not possible. For example, this question, this example 5. See here, you can see one null set. Correct. This is what we are calling null event. Okay, we are calling it as null event. Or this example, tossing a coin, we have one empty set here. This is the null event or impossible event. Okay, null event or impossible event we are getting. Now another example here, you can see getting a number greater than 7. Getting a number greater than 7 when a die is thrown. Is it possible, that one? Because die thrown means what are the options? 1, 2, 3, 4, 5 and 6. Correct? Maximum 6. But what we are telling here, the event getting a number greater than 7, more than 7. It is not possible. Correct? So what will be the answer? That one, this event is an empty set 5. Null event this one. Correct? Nothing. Because more than 7, when we are throwing a die, more than 7 never happen. Impossible event, that one. Null event, that one. Clear? So this is the null event or impossible event. Now getting a number less than 7 when a die is thrown. Die is thrown means, as I told, 1, 2, 3, 4, 5, 6. Correct? Out of this, getting a number less than 7, below 7. So what will be that event actually? Getting a number less than 7, below 7. What are the possibility? Either 1 will come, or 2 will come, 3 will come, 4, 5 or 6. Correct? It is same as the sample space. Yes, correct? It is same as this one, the sample space. This is the sample space. So it is same as the sample space. So the same sample space we are calling a sure event. Surely it will happen, because that is why that is calling sure event. Full, correct? Full sample space happening. That is what we are calling sample space, we are calling sure event. Hope you understood that one. So we are discussing many idea. Now we are coming to some classification of events. Okay, events we are classifying like different ways. For example, classification of event, equally likely event. That word meaning itself, it is clear. Equally likely event. What is the meaning of that one? 2 or more events which have equal chance for occurring. Equally likely means equal chance for occurring. For example, when tossing a fair coin, one coin we are tossing, getting head or getting a tile. Getting head and getting a tile, equally likely event. Correct? When we are tossing a coin, either it will come head or it will come tile. 50-50 chance, equally likely chance. Correct? Equal chance. So these type of experiment, this type of events we are calling equally likely events. So getting a head, that means getting a head option, or getting a tile option. This is equally likely. Either head will come or tile will come. Equal chance for that one. So this is the first classification of event. And second one, mutually exclusive event. Exclude, not include, exclude. Okay. So mutually exclusive event means events are said to be mutually exclusive. They cannot be placed at the same time. Same time, that will not happen. Okay. What is the meaning? Mutually exclusive. That event both should not happen same time. For example, what is the meaning of that one? The event A and B are said to be mutually exclusive. A intersection B should be empty. That means A and B together, it will not happen means empty set. Correct? That means A and B, there should not be any common member. That is the meaning mutually exclusive event. For example, in a rolling a die, one die we are rolling. Getting an even number. Getting an even number means what are the option? Either 2 or 4 or 6. Getting an odd number. What is the option? Getting odd number 1, 3, 5. Correct? What about these two event A and B? See, for example, I can show here. When we are throwing a die, you know the sample space. Correct? What is the sample space? 1, 2, 3, 4, 5 and 6, correct? Now I am defining two event here. One event is A. A means getting an even number, that is 2, 4 and 6, correct? From here only select the even number 2, 4 and 6. Okay, this is A event. And B means getting an odd number. What are the odd number? The remaining number 1, 3 and 5, correct? So this is even option, even number, and this is odd number option. Now what we can say that one, what is the intersection of these two event we can taking? A intersection B equal. What is the intersection? Is there any common number these two? No, 2 is not common, 4 is not common, 6 is not common. So what will be the intersection? It is an empty set, correct? 5, null set. So what we can say, this event A and B are mutually exclusive, correct? Mutually exclusive event, correct? Mutually exclusive events. That means, see, when we are throwing a die, when we are throwing a die, even number and odd number together, it will not happen. Either it will get a odd number, correct? Or we will get a even number. Either we will get 1. 1 and 2 together it will not come, because one of the face only on the top side, correct? That is the meaning mutually exclusive event. So they cannot take place at the same time. That is the meaning mutually exclusive event. So this is the simple example for understanding that one. Just to check A intersection B. If you are getting A intersection B equal to empty set, then it is mutually exclusive. Hope you understood that one. Now, exhaustive event. What is the meaning exhaustive event? Exhaustive event means set of events is said to be exhaustive if they include all possible outcome. Okay, we have many event, for example. If we have more event, that event all union when we are taking, if we are getting sample space, then that we are telling that events are exhaustive event. That means, for example, if A and B are said to be exhaustive, A union B, when we are finding A union B, it should be the sample space S. Then we are telling exhaustive event. For example, before coming to that one, see this example. Is it exhaustive or not? We can check it here. For example, what we need to check here? Just to check what is A union B. Okay, what is A union B? A means 2, 4, 6, correct? Union, what is B? 1, 3, 5. Now just to calculate what is the union of these two. Take all the number, that is the meaning union together, correct? So what are the numbers in the union? 1 is there, 2 is there, 3 is there, 4 is there, 5 is there, 6 is there. Union, correct? Is it same as sample space? Yes, it is same as the sample space. So when we are taking the union of two sets, if you are getting sample space, then we are telling these two events A and B are exhaustive event. Okay, exhaustive events. So A and B are exhaustive event here because union is sample space. So simple idea, exclusive means intersection will be empty. Exhaustive means union will be the sample space. Okay, hope you understood that one. Now another example is here. See, when a fair die is thrown, a die is throwing. First, getting a number less than 4. This is the first event A. Getting a number less than 4. So 1, 2, 3. B event. Getting a number greater than 2. More than 2. That is the B event. So B equal more than 2 means 3, 4, 5, 6. Correct? Now when we are calculating the union of these two sets, A union B. What is the union together? Correct? 1 is there, 2, 3, 4, 5 and 6. It is same as the sample space. Correct? So we can say these two events are exhaustive event. Correct? We can say these two events are exhaustive events. I hope you understood what is the meaning of that one. Correct? So this section there are many basic ideas are there. Okay, we are discussing one by one now. So we discussed what is the meaning equally likely, mutually exclusive and exhaustive event. Now independent event. What is the meaning of independent event? Now we can see what is the meaning actually independent event. Independent, that word meaning itself it is clear. Independent, there is no relation. Correct? There is no relation. That is the meaning independent event. So the occurrence of one event does not affect the occurrence of the other event. Okay, one event happened in one trial. Next, when we are doing next trial, it is independent. If one event happened means it is not, does not depends on the next event. Independent, correct? No connection. That is the meaning. For example, a simple example: a coin is tossed two times. One time tossing, second time tossing. So what are the outcomes? First time you are getting head, second time also head. So head head. First time head, second tile maybe tile will be there second time. First time tile, second tile head will be there, correct? And both maybe tile will be there. So two times a coin is tossing. Okay, first time toss, second time toss, correct? First time what are the option? Either head will be there or tile will be there, correct? Now it is followed by, when we are doing second toss, first time you get head means second time either head will come or tile will come. Now same way, first time you go to tile, second tile what are the possibility? Either head will be there or tile will be there, correct? So how many elements will be there in sample space? Head head, head tile. Okay, hope you understood. Head head or head tile or tile head or tile tile, correct? Four option will be there. So this is the sample space. Now we are defining some event here. A be the event getting a head in the first toss. First toss getting a head, that is A, correct? And B is getting a tile in the second toss. Is there any connection between this one? There is no connection. For example, first toss you got head. Second toss maybe you can get a head or you can get a tile. It is not related to the first toss, correct? So that type of events we are calling independent events. So getting a head in the first toss, it is not related getting a tile in the second toss. Okay, so these are independent event. There is no relation. Now what is the dependent event? Not independent event. For example, see, if you park your car or whatever it is vehicle illegally, if you are park your car illegally, what happened? There is a chance for getting parking ticket, parking fine, you will get it, correct? So it is connected. If you park in the wrong place, automatically what you got? You will get a parking ticket, parking fine you will get it, correct? The police will come, they will get your fine. So this is dependent, correct? What connection is there? If you park illegally, parking ticket, parking fine. So it is connection is there. So this is what we are calling not independent event. Okay, dependent event. So I hope you understood the idea of independent event. What is the meaning of that one? So we discussed all the idea whatever in the beginning, probability theory beginning section we needed. Now we will come to the question 4 from this one. So in the 5.1.1 section, mainly we are discussed about the sample space. How can we find the sample space? When we are how can we find the event? When we are telling two events are exclusive or exhaustive, independent, like that idea. Okay, so we will do some question for better understanding. Exercise 5.1.1. You can see the first question. A coin is tossed twice. A coin tossing two times, correct? So first time tossing, second time tossing, correct? A coin is tossing two times, toss number 1 and toss number 2. Okay, so first toss, what are the option? Either head will come or tile will come, correct? Only two option. Now if you go to first head, okay, what is the possibility? Second toss options. Either second toss head will be there or tile will be there, correct? Now same way, first toss if you go to tile, what are the option for second toss? Either head will be there or tile option will be there, correct? So what is the sample space we can tell, correct? What is the sample space we can write? head or head tile, head tile head or tile head, correct? Now we can read the question. If the second throw result a head, what is the question? If the second throw result a head, so this is the second throw. If you are getting head, see here also head, what happened? A die is thrown. If you go to head option, you need to throw a die, correct? If you throw a die, what are the option will come? You know that one. What are the option? Either 1 will get, or 2 will get, or 3, or 4, or 5, or 6, correct? Here also same, when we are getting a head in the second chance, you need to throw a die, correct? So 1, 2, 3, 4, 5 and 6, like this option will come. Now continue read. Okay, otherwise means if you are getting a tile. Okay, I will show here. If you are getting a tile, so that means here tile, second toss if you are getting tile, that is the meaning otherwise. A coin is tossed. So what happened here? Coin tossed means what are the option? Either head will get or tile will get it. Coin tossing means either head will get it or tile will get it, correct? Hope you understood that one. What is the sample space? Write the sample space. SC equal to. Okay, so we are writing the sample space now, this experiment. So how to write the sample space? First start from the head. First toss, here it is, 1 second, yeah. First toss is head, second toss is head, third toss, third one, 1. Because if you go to head, you need to throw one die, correct? So head, 1. So I am writing first that one, H, 1. This is the first option. Now what is the next one? Second like that one, head, number 2 will come, correct? Now what is the next one? Head, number 3 will come. Then next head, number 4 will come. Then H, 5, correct? Then H, 6 can come, correct? Now what are the next option? Head, tile, head, correct? So I can write head, tile and head. What is the next option? Head, tile and tile, correct? Now go to the tile next option. So tile head 1, tile head 2, tile head 3, tile head 4, tile head 5, tile head 6, correct? Now again tile head, coin tossing time, correct? So tile head and tile and tile. Hope you understood, correct? How many elements are there in the sample space? There are 16 outcomes are there, correct? There are 16 outcomes are there in the sample space, correct? Because 1, 2, 3, 4 up to 6 option. Another 6 option, 1, 2, 3, 4 up to 6, so 12. Then head tile 13, 14, head tile again 14, 15, correct? So sorry, 15, 16. So totally we have 16 outcomes are there in the sample space. Hope you understood this question. Okay. Now we will go to the second question. What is the second question? A bag contains 4 balls. We have a bag here. This bag contains 4 black balls are there. Okay, 4 black balls. So we can say this is ball number 1. This is ball number 2. This is ball number 3. And this is ball number 4. Correct? So this is the bag. So bag containing 4 black balls are there. Now what we need to do? What is the sample space? We need to calculate the sample space of the experiment. Consists of choosing 2 balls at a time. Choosing. You can underline this word, noting that word choosing. Choosing means combination. Okay. We are studied 4th module permutation and combination. Combination. Choosing 2 balls. Okay. Select 2 ball. Okay. Choose 2 ball. So choosing 2 ball. So how many balls we have? Totally 4 balls. From 4 balls, choosing 2 balls at a time. Correct. So we can write 2 balls, okay, can be selected or can be choosing, can be selected from how many balls? 4 balls, correct? This is the idea actually. We have choosing 2 balls from 4 balls. So how many elements will be there in sample space? If it is like this, okay, number of elements in sample space, number of elements in the sample space equal to what we can do, combination of 4 balls taking 2 at a time, correct? So 2 balls we are taking out of 4, 2 at a time. So combination of 4, 2. You can check by calculator what is that number. Combination of 4, 2 means there are 6 ways we can choose. 6 ways we can choose. So sample space, how many elements will be there? 6 elements will be there, because 6 ways we can choose that one. Now we can assume what is that sample space. What is that sample space? That is the question. So S equal to, what is that sample space? Can you tell me the options? 6 options. What are the balls? First we select 2 ball. For example, ball number 1 and ball number 2 I am choosing. This is the one option, correct? What is the next option? Ball number 1 and ball number 3 I am choosing. Second option. Ball number 1 and ball number 4 I can choose. Third. Then ball number 2 and ball number 3, correct? Then ball number 2 and ball number 4, and ball number 3 and ball number 4, correct? So how many options are there? 1, 2, 3, 4, 5, 6 options we are getting. 6 ways we can choose. So number of elements in the sample space means combination of 4 total ball, 2 selecting at a time. So 6 ways. So 6 elements will be there. Okay. So once we calculate the number of elements first, you can write that sample space options very easily. So there are 6 elements will be there. So this is the question. Okay. Hope you understood that one. So that word choosing, very careful. 2 balls are choosing. 1 means no problem. 2 balls are choosing means we need to take the combination. 2 balls or 3 balls or 4 balls, like that. If you are choosing, we need to take the combination. Okay. So this is the idea here. Hope you understood. Now question number 3. If 3 coins are tossed simultaneously, okay, how many coins are there? 3 coins are tossed simultaneously, okay, then write the resulting sample space and describe the following events. We need to write the following events from that: getting all head, getting at most 2 head, all head, at most 2 head. Then show that A and B are mutually exclusive and mutually exclusive and exhaustive events or not. Okay. So we need to do many things here. First we need to find the sample space. After that we need to check these events. Then mutually exclusive or mutually exclusive or exhaustive, we need to check that one. Okay. So we will come to the question. 3 coins are tossed simultaneously. 3 coins. Okay. For example, we have first coin, okay, second coin and third coin. We are tossing simultaneously these coins. Okay, first coin, we have second, and we have third coin, correct? We are tossing simultaneously these 3 coins. So what happened? First coin, what are the options? Either head will come or that one tail will come, correct? Now first coin show head means second coin, what are the possibility? Either it will show head or tail, correct? Same way, first coin choosing showing tail, okay. After that second coin, maybe it will come head or tail, correct? Now when we are going to the third one, third coin, correct? Same option. After head, maybe it will come head again or tail will come, because we need to write all the possibility, correct? After tail, maybe it will come head or tail. After head, maybe again it will come head or tail. Same after tail, it will come either head or tail option, correct? This is the tree diagram representing that experiment. Okay, so these are the options we are getting. Now you can write the sample space easily, correct? So what is the sample space? You can check. S equal to sample space equal to, okay, set of all possible outcomes. What are the possible outcome? First head, second coin head, third coin also head. So what is that option? Head, head and head. First one. What is second one? First coin head option, second one tail, third one first coin head, second head, third one tail, this one. So we can write head, head and tail, correct? Now we can write head, tile and head. Head, tile and head. Then head, tile and tile. Then tile, head and head. Then tile, head and tile. Then tile, tile, head. Then tile, tile and tile. Okay. So how many elements are there? You can check 1, 2, 3, 4, 5, 6, 7, 8. So 8 outcomes are there, correct? So we can write here 8 outcomes or 8 elements are there in the sample space. So this is what the first we need to do. 3 coins are tossed simultaneously. Write the resulting sample space. This was the first part of the question. Now I am going to the second part. Describe the following event. We need to calculate this event. What are the event? Getting all head. That is the first event. So I am answering here itself the first part of the question, A part. Getting all head. A means getting all head. So what will be that option? Getting all head. You can see the sample space. Where is the all head coming? H, correct? This is the option, all head, correct? So I can write the answer H and H. This is only the option, all head, correct? Now, this is the first part. B part of the question now. B. Capital B means getting at most 2 head. At most means what is the meaning? Most. Most means maximum. Okay? Maximum. So maximum 2 head. What are the options? Maximum 2 head. Maximum 2 head means, okay, maximum 2 heads. Means what are the meaning? What is the meaning? 2 head is okay. 1 head okay. 0 head okay. Okay, 0 head or 1 head or 2 head. But more than 2 head not possible. 3 head don't take. So what are the options we are writing that one? Either 0 head. 0 head means tile and tile, correct? There is no head. Maximum 2 head. So 0 head no problem. Now 2 head, 1 head we can write, 2 head we can write. So from this sample space we can take it. For example, here only 2 head we can write. Here 2 head we can write. Here 1 head only we can write. Here 2 head we can write. Here 1 head only we can write. Here also 1 head. Okay. And here also we can write. But only the first one don't write. Triple head, correct? Because maximum 2 head. So what are the other options? Either we can write TTH, okay, or THT, or we can write THH, or we can write HTT, or we can write HTH, or we can write HHT. Correct? How many elements will be there? 7 elements. 1, 2, 3, 4, 5, 6, 7. Except HHH, 3H. Okay? So this is the second part of the question. Now third part, C part. That is important part, C part. Show that A and B are mutually exclusive and exhaustive even. What is the meaning mutually exclusive? We discussed A intersection B should be empty set. Check that one. Exhaustive means what is the meaning? A union B should be equal to sample space. We need to show this one. Okay, so we can check here. What is A intersection B here? It is clear. A set we have, B set we have. Is there any element common? No element common, correct? So we can write no elements common. No elements common. That means what is A intersection B? Equal to the empty set. 5 is the answer. So it is mutually exclusive, correct? That means mutually exclusive. Hope you understood that one. Just to check the intersection. Intersection, if you are getting empty, that is mutually exclusive. Now what is the second, the next part? Exhaustive or not? We calculate A union B. What is the A union B? All the elements, correct? What are the elements? First HHH, then we can write TTT, TTH, THT, and THH, and HTT, and HTH, and HHT, correct? All the options are there. 8 elements are there. It is same as the sample space. Yes or no? Yes. So what we can say? It is exhaustive, correct? exhaustive event. Exhaustive events. A and B are exhaustive events. So that is the third part of the question. Just to show that, you need to show mutually exclusive and exhaustive event. Mutually exclusive means intersection should be empty. Exhaustive means union should be the sample space. We need to show that one. That is the third part of the question. Hope you understood this question. Okay, now I will go to the question number 4. Question number 4 here, you can read. A coin and a die tossed. Coin is tossing, die also tossing together. Okay, write the sample space of the event. Sorry, it's a sample space of the random experiment, and describe the following event: getting a head and an even number, getting a prime number. A and is another question. Are A and B are mutually exclusive? If not, why? Why not mutually exclusive? This is what our question. Okay, so we will do that question. We will start the question. A coin and a die are tossed. Correct? We have a coin. We have a die. We are throwing these two. We are tossing coin and throwing a die. Coin means what are the options? Either head will be there or tail will be there. Correct? Now followed by a die. Die means how many options will be there? 6 options. Correct? So what are the 6? 1 will be there, 2, 3, 4, 5, 6. Correct? Now after tile also a die throwing means we have 6 options will be there. 1, 2, 3, 4, 5 and 6. Correct? So write the sample space. That is the first part here. So I can write S equal to sample space equal to, what is the sample space? Head 1, first one. So H1, then head 2, H2, head 3, H3, H4, H5 and H6. Correct? Now what is the other one? Now we go to tile. Tile 1. So T1, T2, tile and 3. Tile 4, T5 and T6. This is the sample space. Correct? 1 to 6 in both cases. Now we will answer the first part of the question. A part of the question. Okay. Capital A means, what is the even capital A? Getting head and an even number. It should be a head and even number. That means coin should toss showing head and die will show even number. So for example, head 2, head and even number. Head 4, H and 4. Head 6, head and even number. Correct? So how many outcomes we will get in that event? That event we are getting 3 outcomes. Correct? What are the 3 outcomes in that event? A equals head 2, head 4 and head 6. Hope you understood. Only 3 outcome, head 2, head 4, head 6. Now we will go to the B part of the question now. What is the B part of the question? Getting a prime number. You know what is the prime number, correct? What are the prime numbers? Prime numbers are starting from number 2, okay, 3, 5, 7, 11, 13, 17, like that it is continuing. These are the prime number. What is the meaning actually prime number? We will discuss in module 6 in detail, but prime number already you know what is the meaning. Prime number means a number having only divisors. What are the only divisors of that number? Only divisors are 1 and the same number. Okay, 1 and the same number. Okay, that number, prime number means only divisors are 1 and the same number. That type of numbers we are calling prime number. For example, number 5. What are the divisors of the number 5? We can divide by 1 and we can divide by the same number. We cannot divide it with any other number. Perfectly integer we will not get it. 5 by 1 we will get 5. 5 by 5 we will get 1. If you divide 5 divided by 2, what happened? 2.5. Correct? It is not an integer number. So it is not a divisor. So only divisors are number 1 and the same number. That type of numbers we are calling the prime number. So prime numbers starting with the 2 is the number starting, then 2 3, 1 is neither prime nor composite. Okay, so starting from 2, that type of number. Okay, now return back to the question here. Getting a prime number. Prime number means getting a prime number in the die. Head and tail it will not come. Coin same, either head or tail. Coin either head or tail, but die showing a prime number. What are the options? So B equal to, you can say what are the options? Okay, what are the options? H2, correct, first option. Head 2 is a prime number. H3, head 3 is a prime number. H4 is not a prime number. H5 is a prime number because 5 is a prime. H6 is not a prime number. Then what is next one? T2, tail and 2. Head or tail no problem, but second number should be a prime number. T2. Then T3 is a prime. T5 is a prime number. Correct? So these are the B set, getting a prime number. Hope you understood that one. Now we will go to the main question. Are A and B are mutually exclusive? Why? Okay. Mutually exclusive means what we need to do? We need to check A intersection B. Correct? Should be empty set. Then only mutually exclusive. Otherwise not mutually exclusive. Correct? So what you do here? We need to calculate what is A intersection B. Okay. So C part we can do. We are going A intersection B equal to. What is the intersection of these two sets? You can see common elements. Correct? What is the intersection? Here H2. H2 is common. Correct? Any other common? H4 not common. H6 also not common. So only one answer we are getting. What is that one? A intersection B is H2. So what we can say? Is it mutually exclusive? No, because mutually exclusive means we need intersection empty. 5 null set. Correct? But here not null set. Not equal to 5. So what we can say? Not mutually exclusive. Okay, not mutually exclusive events. A and B are not mutually exclusive event. This is what our question here is there. Our question, are A and B are mutually exclusive? No. Why? Because A intersection B is not equal to empty. Correct? Not equal to 5 set. One element is there common. So we cannot say mutually exclusive. Hope you understood that question. Now we will go to the next one. Question number 5. One more question, the last question. A die is thrown. A die is thrown. Okay, we have die. A be the even, die shows number 4. B the even, die shows even number. Are A and B are mutually exclusive or not? That is the question. So die is thrown. Correct? A die thrown means what is the sample space of the die is thrown? Either 1, 2, 3, 4, 5 or 6. Correct? A die is throwing. Now, what is A here? A be the even, capital A be the even, die shows number 4. Only one option, number 4 only. Correct? Die shows number 4 means number 4 itself. Now, B. What is B? B equals, B be the even, die shows an even number. What are the even number in the die showing? Either 2 or 4 or 6. Correct? Now what we need to do here? The question, are the even A and B are mutually exclusive? What we need to calculate mutually exclusive? We need to check what is A intersection B equals. Correct? What is A intersection B? What are the common elements? Take it. Is there any common elements? Yes. What is the common element? Number 4 is common in both. So what is A intersection B? Number 4. So it is not equal to empty. Correct? Not 5 set, not empty set, because number 4 is there. Correct? So what we can say the answer? Are the events are mutually exclusive? No. Correct? No. What we can say? A and B are, these two events are not mutually exclusive. A and B are not mutually exclusive. I hope you understood the question. So this 5.1.1 exercise we are discussed only about the sample space, okay, and 5.1.2 we will discuss about the probability. Okay, after this recorded class I will upload that section, that exercise 5.1.2, that is dealing with the probability theory. Okay, how to calculate the probability of different experiments. Okay, so that's the idea. So I hope you understood this sample space evaluating this exercise. Thank you for watching. Please subscribe my channel for getting more recorded classes. Thank you very much.